start recording officially, that way I don't forget to do that. What I wanted to do, though, was look at the calendar first.
Oh, I don't want to see the camera.
You don't want to see the calendar, I know. But you know why I want to? Because I'm done preparing stuff for like a month. It's your turn.
Woo!
I have one more formative assessment. I will let you know when that's available, but my plan is to sort of incorporate a wrap-up / discussion of the presentations that you've heard and some common features of that. We did at the end of the advanced longitudinal class, and I felt like that was a useful sort of thing, as opposed to like shoving yet more material at you, which is not my plan. But that being said, we have Tuesday class next week. I have example 5B here, but we'll see how far we get today. If you all just want to show up and like with questions about your analyses or whatever, like that would be fine too, I think. At this point, I'm more worried that folks are knowing what they're doing and ready to present after break than necessarily covering every detail of the handout. I do not have office hours planned for when we are not in classes on the 24th or 25th or 26th, but I am going to be in town. So if you want to set up a Zoom meeting to chat with me about any of that, I do have some availability working around the rest of the stuff here. But then, yeah, we have 3 days of presentations. You should have the schedule in Icon sent over an email and to various other places. There's also an assignment of peer review in the last column. So each of you is responsible for watching someone else's presentation. I made sure they're not on the same day or ahead of time so that you can hopefully avoid that crosstalk.
What did you assign those? Whose presentation we are doing? Because I didn't look. Okay.
It's in the schedule. It's the last column.
Okay.
Yep.
Perfect.
Yeah, I tried to match it in terms of timing and also potential interests or like things like that, but
cool.
It's somewhat random other than that. And those peer reviews are due via email a week after the presentation is given. So you have a week to go for that. And I want you to email them to me and to the presenter. That's the instructions in the document. So those templates are right here. You can just download the Word document and answer the questions in it. So Project Tech Check-In is due Monday, which, by the way, is Jonathan's birthday, if anybody wants to acknowledge that next week, since he does that to me.
I should have done, if I had known yesterday.
Yeah, it's on Monday. It's a big one, actually. It's the last one in his 40s.
So he is square.
He's
only 40?
No, in his
49.
40s. He was not 50 yet. He's turning 49.
Wow.
Yeah,
I saw
so.
Oh, wow. I didn't really sorry. You didn't call them for her.
He is 10 months older than me, so it's I keep track of that. So for 2 months out of the year, we're the same age, which is happening right now. But anywho, yeah, so I will celebrate his birthday by reading your check-in documents, as one does. And I will get you feedback as soon as humanly possible so that you can keep working, okay? And TAs are not planning on having office hours next week either, since classes are not officially in session, but it's up to you whether you want to bother them. How's that? I'm assuming there may be ongoing conversations that I'm not privy to, and I don't want to interfere with any of that if you're talking to folks about their projects already. So, all right, that's what we got. And then, yeah, peer reviews come in. If things go sideways, so let's say despite your best efforts, despite starting it well and ahead of time, you end up in a place where you're not happy with your presentation and you don't feel like it represents your best work and you'd like to redo it. In life, that is never possible. In this class, it is. So if things go sideways and you decide that you want to revise your presentation, then you can record a video and send me a link to access it somehow, and then I will reevaluate your work. And if you look at your score and you're like, this score isn't very good, but I just don't have time to do anything about it, I've got other fish to fry, that's fine too. So everything is optional with respect to doing any kind of revision on that. But all right, so then, shall we talk cross models?
By the way, did you guys say Northern Lights?
I did. It was really cool. I saw the picture that my husband took after I went to bed, if that's what you mean.
Oh, you didn't. I saw yesterday was very light.
Yes, one moment.
You have a picture?
I do. And since we're interested in wasting as much time as possible before we talk about stuff, right? That's the vibe that we're getting in here. Not making fun of you, making fun of me. I'm the one over here telling stories and stuff. Okay. This is outside our house in Coralville.
Oh, that's awesome.
So I put this up on the Facebook. I figured this was Facebook worthy.
Yes.
So, yeah, pretty cool. I've seen a whole lot of interesting skies. The one time of the year the Midwest has pretty scenery. Wintertime sunsets in the Midwest are prettier than elsewhere. It's a weird thing. There's some weather reason for it. Erica's not having it. No, let me have this, okay? The Midwest has nothing else to offer. Let me have wintertime sunsets for the win. Those of you who are not from here understand. You're allowed to nod.
Sundogs are another fun one.
What is it?
Sundogs.
Sundogs. I don't know that one.
So in the winter, there's more crystals in the atmosphere than usual,
Oh, okay.
and so the sun comes down. You actually get a like rainbow in the sky effect around it, if depending on
That's cool.
Yes.
And we also have thunder snow. That is a thing. I've heard it. Question.
Okay, sorry, not this question. You also got the blue light. I only see the pink and the green, but why you got the blue light?
That's what the picture took.
Yeah, it was interesting. Northern Lights. Usually it's only green, or potentially blue, but the red.
I never saw the red before. This is my first time.
I think maybe it's because it's so strong, perhaps.
It's pretty cool though, I gotta say. So.
The one you have is even fuller than the blue one.
You what?
You all have the blue color.
Yeah. It's cool. All right, we gotta get on task. At least for a little bit. So what are we talking about again?
Cross-level classifications.
Yeah, cross-classified or cross-random effects. What situations are those models for?
Level 1 variables interacting with level 2 variables.
That's a cross-level interaction.
Oh, sorry.
We're talking cross-classification.
Oh.
Similar words, but not the same meaning. I'm going to start calling on people that I know this. Dan, I'm going to call on you.
Can you repeat your question one more time?
My question is, can you give me an example of when a crossed model
Yes.
would be needed, such as the one you're currently working on?
Yes. Yeah, I can show. Yeah, sorry, I was
No,
thinking about
no
that.
worries.
So, like, I have using my data as example, I have 118 teachers who are rating 24 items, and then each item also listed in 3 categories. And then, so I want to see the person variance among those items, item variance also within those different categories.
Yes, so we have responses, one response from each teacher to each item. So then essentially responses are nested in teachers at level 2, responses are nested in items at level 2, teachers and items are crossed.
Oh.
And we can see to what extent item mean differences are predicted by which subscale the item is supposed to be assessing. We can see to what extent teacher mean differences are predicted by like their age, what kind of classes they teach, stuff like that, teacher things. And potentially you would have level 1 predictors that are response specific. So for instance, if you randomize the order of your questions across subjects, then what order the question was in would be a response level predictor because it would be unique to that combination of that item and person. So if you had a test where you thought learning would happen, like you expect people to get like faster or something up to a point, putting in the order that the trial is would be a reasonable thing to do for that. But if you had the same order across items, then that would be an item characteristic instead. Like if you didn't randomize it across persons. Yeah, so that's one situation, persons and items. That's very common in experimental designs. Nowadays, mixed models are used a lot for that. There's a class over in psychology that focuses, I think, on that context in part. And I'm going to get your name correct today. Is it A?
Yes.
Hey, I missed on 2 of the vowels. There's 3 left. I'm going to get it right. You have a crossing in your analysis, right? Or at least you thought you did, but it didn't turn out to be there.
Yes.
You want to tell the story real quick?
So students are nested in discussion section, and that section is nested in semester, but it's also nested in TA. That's how it looks.
Mm-hmm. But the TAs are across multiple semesters, so then there's a crossing with respect to that. But fortunately, you have no TA variance, right? So, hallelujah, your model simplifies down to just a mere 3-level nested design. Mm-hmm. And Vladimir, the data you often talk about with your collaborator Rong Su, we have people within years, within states. Technically speaking, years and states would be crossed. But once you put in some kind of fixed effect that controls for mean differences across years, that year crossing goes away and you're left with just basically state by year as level 2 interaction variance. Mm-hmm. Let's see, who else? I don't think any of you have a crossing in yours, but you could. Like, I don't remember your data, but I remember that you're from counseling and that you do clinical stuff with people. Like, so if you had clients in a group therapy session and they changed groups. So something like Alcoholics Anonymous, where you can just show up to whatever meeting you feel like. If you wanted to somehow collect data about that design, then you would have individual occasions nested in patients, like clients, and then patients and groups would be crossed because you can change group membership depending on where you want to show up. So, employees under multiple supervisors? I'm going to make up some data for you too.
Could,
Yeah.
Or on different teams in the same organization.
Yep. So crossings in that design? Do you have any crossings?
Students taking a class in different sections because they failed.
Yep. Students who need to repeat a course, then essentially you're crossed or whatever.
Yes.
Let's see, Erica, do you have any crossings in your life I can make up data about?
I've just done,
You just did what? People and items? Yep. Oh, by the way, that chapter, the proofs just came back the other day. They added the word quantitative to the title, but otherwise it was okay. I thought a chapter about multi-level modeling would sort of imply that it's a quantitative research technique, but I guess it's not specific enough. But I've never heard of qualitative multi-level analysis. Is that a thing? Qualitative multi-level is a thing?
I don't know.
Okay, that's what I'm asking. I don't know anything about qualitative. It could be, for all I know. Multi-level is a word that has a lot of different meanings, like multi-level marketing is a scam, like pyramid scheme or whatever. So, anywho, you get the point though, right? When you have multiple sources of nesting, but they're not necessarily hierarchical. So that's what these models are designed for. And programs differ in the extent to which they can easily adapt to have multiple sources of cross-random effects. I've had no problem with these models in SPSS, SAS, or R so far. I've had problems in Stata. So just keep that as an aside. I have some fake data here that I built an example out of from the Hawks textbook. So we have 1,000 students nested within 50 primary schools and 33 secondary schools. So those are crossed at level 2. We have denomination status for the schools as level 2 predictors and child socioeconomic status as a level 1 predictor. So because this is a level 1 predictor, what are we going to need to worry about for it?
Smush slope.
Smush slope. How many smush slopes?
Would be 2, 1 for each cluster.
That's right. So potentially you would have 3 different slopes for the effect of SES. Primary mean differences, secondary mean differences, and within differences across the kids. In this case, there would actually potentially be a 4th because you have between 1 to 6 kids per unique combination of primary by secondary. So that actually could provide yet another contextual effect, so up to 4. So same principle as previously, but just with a higher level of complexity. So what we had done previous was talk about data aggregation stuff so that you can aggregate up to the level 2 to get descriptive information for each source of the level 2. And we had looked at empty models, I recall. So starting with adding a primary random intercept only to make it just a standard 2-level nested model. This is on page 3. That helped the model as you might expect. Then we added secondary school as a crossed random effect at level 2. That also helps the model, so we keep those. At this point, we talked about how much variance is there of each kind. And this is where I would use the term proportion of variance rather than ICC. I think it will be more understandable. And because these are orthogonal variance components across level 1 kids, level 2 secondary, level 2 primary, we can sum them up into one sort of total to talk about, like, relatively speaking. So, for instance, if you had this type of design, an effective visual for this would be something like a pie chart. You know, of the total, like how much of it is this and versus this. So in this case, we have 23% of all the variance in achievement in this 9th grade outcome has to do with what school you go to before, so primary school. 10% has to do with what school you go to now. And the remainder is differences between kids for unknown reasons that after we've controlled for schools. So that's going to be the lion's share of the variance in most of these cases. So then here are the results. Here's how I got them in Stata as well as in R. And I had made the point that the ICC function in R isn't necessarily obvious as to what it's doing. But if you put by group, then you get the same numbers as proportions of variance. If you leave off by group, then you get the total, which is the expected correlation of students who have both in common, according to this additive model. Then we try to add a random interaction term. So a random primary by secondary intercept. And this one did not help the model. Looks like we don't need it. And it changed the expected intraclass correlation of students who have both in common by a very small amount. So it looks like there's nothing extra. There's no extra source of correlation if you have both in common in these data. Then I tried to fit the same empty model with random primary, random secondary, and random interaction for SES as a continuous predictor. And we got very strong evidence of fake data. That's what I would call this. There's no variance in economic status across schools whatsoever. There's a tiny bit for the unique ID. However, this is something we haven't talked about much, but I know why this is here. It's an artifact of, getting there, looking for a box. That box. This is the number of students per unique combination. You'll see that most of the unique combinations have only one student in them. So if you fit a random effect for a cluster that has one person in it, which is essentially what is happening, then the variance from that person is the cluster. So this variance due to unique ID, to me, is completely an artifact that 60% of my sample, like their variance went up to that level. So you are the cluster in that case. So keep that in mind if you have singletons in your analysis, that can potentially inflate your level 2 variance because that singleton is contributing to the group level only. You can't have within group variance if you don't have more than one person from the same group. So it is okay to have singletons in multi-level analysis, but it can cause problems like this potentially. So that, to me, is an artifact. Nevertheless, though, just in case this actually happens in real data, that you have higher level variance in a variable like socioeconomic status, I want to show you how to put it in the model properly. So that's where we left off. My giant disclaimer here. Even though SES doesn't have any upper level variance, I'm going to show you how to act like it did. But if you were to get something like this in your results, where there's no evidence of higher order variance, that means the predictor isn't going to contribute at that level. So you're allowed to sort of skip it in that case. I'll give you an example of a student's dissertation that I'm helping with right now. They're looking at how standardized test scores for science change across years as a function of whether the district has implemented a new way of teaching science. So every year, they're testing a different set of 8th graders. So we have students within years within districts. And one of the moderators of interest is, say, for instance, free and reduced lunch status. The science program is supposed to narrow the gap in achievement between students who are doing well and doing less well, and some of that is going to be associated with poverty. In that data set, there are differences between students in whether they get free lunch. Like, that's the obvious one. There are differences in districts as to what proportion of their students get free lunch. That one is also to be expected. But there was very, very little variance across years in how that proportion shifted within a district.
Interesting.
Yeah, so it's the district, like, context is relatively constant, and kids are different from each other, and districts are different from each other. So in that case, what I had advised is to do cluster mean centering within a year district combo, so that the level 1 variable is purely within. Skip level 2, because there is no variance across years in free and reduced lunch, and then put in the district mean at level 3. So then we have a district contextual effect, and we have a within district year student effect. So that's how I would handle something like this in practice. If there really was no variance there, there's nothing for the predictor at that level to do because it is functionally a constant. Does that make sense? Question?
How would you code skipping a level 2?
You just leave it out of the model, essentially.
So the level 1 would have your 3, and then you're like this colon this colon. I'm thinking about R.
Level 1 would be the original predictor minus the district mean for that year.
Okay.
So it's student free and reduced lunch minus that year's district
Mhm.
mean. That withinifies it completely.
Okay. Right.
And then you could have a between effect for differences between years, but that, like, in
Was
that data
minimal.
set, it looked like this.
Right.
There wasn't there. So there's no point in asking a constant to become a variable,
Gotcha.
is the way I think of it.
Mhm.
And at level 3, though, there was a signal there. There were district differences
Mhm.
in the proportion of kids, and so that goes into the model at level 3.
Okay.
So this can be helpful in designs in which you have small samples at certain levels. Like, if you don't have to have something in at every level, then I wouldn't do it. But doing this kind of detective work ahead of time will tell you which levels a predictor is eligible to contribute to. So we're going to do some level 2 stuff to start with, including an interaction term. Because why not? I haven't had enough of those in my life. So I'm adding in P denom, S denom, and their interaction. So if we look at the subscripts here, order matters. So CPS, not Child Protective Services, that is child within primary and secondary.
Mhm.
So then this gamma right here is 010, because this is the first predictor of P in the middle for primary. Likewise, this is gamma 001, because this is the first predictor for S for secondary. And can you guess what it would be if we added something for child? Yeah, 100 for the first predictor of the C. So each of these is like its own index column. That means that if you were to add like 10 of these things, you'd have to start introducing some kind of comma system to, like, denote what they are. That's where parentheses could potentially be helpful too. But let's hope that you're not at the point where you need commas in your notation. That means you have a really big model at that point. Now this one, this is the interaction between the denomination of each school type. So this is 011 for the same reasons that this is 1 and this is 1. Hang on, I screwed up I put one extra something in here. There we go. Is that it? Nope, that's not
No,
it.
you need another 0 somewhere.
There it is. Okay. Yep. So if I take this one and I bring them together like that. So if you see numbers in more than one spot, that's an interaction of some kind. And we still have our same model for the variance that just has main effects of primary, secondary, and child. Level 2 intercept, 2 level 2 intercepts. Yeah. So any questions on notation or the idea here? Yeah.
So usually when we do interaction, how do we determine which pair we want to do? Or usually if we do interaction, we just put all the pairs, every possible pair.
I don't think you have to try every possible. I wanted to do this sort of for pedagogical reasons, to reinforce interaction terms again, and to try and talk about explain variance and think about what each of these should be targeting. But I would say in practice, you would want to have either a research question or some kind of theoretical motivation before you start digging into every possible interaction term. I'm sure there are models that would run through every possible combination and tell you what's there, but then you're left having to try to pretend like you foresaw that result and that it was on purpose and it wasn't just like randomly chosen by an algorithm, and that becomes the part that I think is more difficult to justify unless your intent is only to maximize prediction and not to talk about explanation. But yeah, I like interaction terms. A lot of research questions require them, so I just want folks to keep getting practice with this. I'm going to do this in my next class too, if you want even more.
Mm-hmm.
Yeah, it's one of my favorite things, okay? Just let me have this.
It's your happiness.
The 2 kinds, it's down from 4, it's only 2 now.
Somebody got booted.
No, I just went from the more, it's like more this or less this. Like I just go more or less now instead of the positive negative because the sign matching is all you got to keep track of.
Mm-hmm.
But anywho, so I'm throwing in these things. Here's what we get. Big pile of nothing in our fake data in terms of significance, but we're going to go through it and interpret it anyway. So there are only 50 primary schools, right? Mm-hmm. And I think there are 33 secondary. Mm-hmm. So keep in mind that these 2 effects right here are going to be relatively underpowered because they are based on the sample size at that level. So if you want to have a lot of power to detect people-level predictors, you need a lot of people. If you want to have a lot of power to detect group-level predictors, you need a lot of groups. If you want to have a lot of power to detect item predictors, you need a lot of items. You sense the trend here? It's the same idea. So in this case, what happens if your primary school is denominational, if it goes from a 0 to a 1? What happens to mean achievement? Yeah, this is a finger question. Up or down? Yeah, up a tiny bit.
Non-significantly, but.
Yep. But yeah, that's the T. This is, I can't tell which is T, which is P. That's not a good sign.
No, they're both small.
Yeah, I know
TP.
you can all look at a p-value column and know how to scan through that. I'm more interested that you know what the direction of the stuff means. So now here's a bigger question. What variance component should this have explained? We got 2.
Level 2.
Which level 2?
Primary. I would hope.
Yeah, it's primary denomination. Therefore, it should explain primary variance. And, well, here's a problem with my little function. It did not anticipate that cross models would have 2 different kinds of intercepts. So I need to add another column to this. But
I will identify. I have 4 lines in my output. I identified what 3 are. I have no clue as how the 4th one was
it's
made.
up here, so like it
No,
should at least
I meant,
match.
but I mean
yeah.
on mine though.
Mm-hmm.
My data's like, I was like, what? What's that?
Well, I will be issuing you all refunds for the R functions that you purchased from me. Oh, wait, that didn't happen.
I'm joking. I just, you were identifying issue.
Yeah, I'm just like, oh, yeah, it's the intercept, duh.
Mm-hmm.
But yeah, it should be this one. So about 1.5% of all the reasons why some primary schools have higher achievement have to do with their denominational status.
Cool.
Yeah. So you could argue that this is not significant, not just because of a lack of power, but a lack of effect size. Like it's really, there's not much here to be found. What about S-denom? What happens if your secondary school is denominational? Goes up a little bit. What should that one have explained? Don't think too hard.
Level 2 secondary denomination.
There you go. Yeah, the S kind, because this is a secondary school characteristic. It explains why secondary schools have different mean achievements. Those that are denominational are a little bit higher, but not significantly. Last but not least, let's talk explain variance first. Which one should this one have done? This is tricky. It's not both. This is a related concept to the idea of systematically varying effects.
Is it level 1?
It is level 1.
Because of what's in common is peoples or the child?
In this case, because we dropped the random interaction, that's what it would have explained, is the unique combination of primary and secondary. Maybe people who are in both denominational, like that,
Mm-hmm.
that's an extra over additive effect, potentially. If we had that random interaction variance for a unique combination of schools, it would have explained that. But because we don't have it, because we didn't need it, it's explaining level 1 instead. And that is also evident by the difference in degrees of freedom. So this one looks very different because this is being treated as a level 1 effect. Now this is a straightforward pattern. Everything is positive. So what is this interaction term doing to the main effect slopes? Up or 1?
Up.
Up. Okay, I have 1 vote for up.
Up only when they've gone to both.
Let's talk about it in terms of what they do to slopes.
Oh, sorry. Just in general, up if. Actually, wait.
Yeah, the 4 patterns is they take each of the main effect slopes and make them either more positive, less positive, more negative, or less negative. Where more something means a stronger effect and less something means a weaker effect.
Make both of them stronger.
It's making both of them stronger. So the way that I would express this is that this effect is specifically for 0 schools for the
Mhm.
interacting variable. So I didn't say that earlier, but I should have. So this is for non-denominational secondary. This is the effect of denominational for primary. This benefit, we'll say, of 0.07
Mm-hmm.
is stronger by 0.16 in secondary schools that are also denominational. So there's an over additive, like a bonus if you are denominational for both, that would not be anticipated from just the contribution of each additively. And the same is true here. So this is the effect of secondary denominational, specifically when primary is 0 as the moderator.
Mm-hmm.
This effect becomes stronger by 0.16 in primary schools that are also denominational. Yep. So the key in talking about an interaction term is saying what it does to its constituent main effects as the moderator increases. The when they're both 1 thing works in this case alone, but it falls apart when you're talking about like numeric variables. Because then it really is
Fair
per
enough.
1 unit
Yeah,
change.
yeah, yeah.
So, yep. We're going to be practicing this at 2 o'clock. You're like, oh, it's only 1:08, folks. Hey, you all get to leave at 1:45. Me and Michael have to stay.
And we'll be practicing.
Yeah, and Erica and Vladimir are like, welcome to my world. I've been sitting in front of you for 3 hours twice a week for 4 years now. I didn't forget.
They get twice the knowledge.
Yes, well, would you say, so this is your, second time for you listening into this class, maybe second or third for you? Like, do you feel like you've benefited from hearing it again?
Yes.
Yes, like I've read the Steiners and Bosker book probably a dozen times in my life, and I get something out of it new every time I go back to it. Like this stuff, it's levels, like not, pun intended, but it really is like levels of specificity and understanding. You can have the basic concepts, but then you're always discovering nuances that you didn't consider before. So there's just a lot here. Good foundation. That's all. Like you have a solid foundation, then you can teach yourself some of the rest of it, and then you can recognize when other folks are going to lead you astray.
I was in the wrong class.
You were in the wrong class. We are here now.
But the foundation
The foundation is different.
was not great because it was not connecting to what you teach.
We all have a different way of doing things, but I will say also, the same is true for workshops, that there is a very easy misconception that you can sort of absorb that I'm gonna go take this week-long workshop and then in 5 days, I'm gonna know everything there is to know about multi-level. And no, absolutely not. And, because I can shove an entire semester's worth of content into 5 days, but it doesn't mean your brain's gonna, like, gel it all. So I think workshops are really good for folks like where you're at. You've been through the class, you've tried to do things on your own, you feel like you might want more training or more connections, especially if you tried to pick it up and then go to a workshop. That way you can be the person with your hand in the air.
Or refresher.
Yeah, like it's beginning, like for the first pass at something, workshops are terrible. So having a foundation is a place to start. But my hope is that you'll be able to learn things as you continue in your careers, because this field will continue to evolve. So anywho, I'm off my soapbox now. But yeah, this is like one of the nuances that I didn't think about until I was building this handout 2 years ago, is what happens if you have an interaction between two different kinds of level 2 predictors? It would explain the U and its equation if there, but we don't have a random interaction, so it has to explain residual. Okay, questions, comments? All right, 3A, child SES. So there we are, gamma 100, SES, CPS, and 4 was in the mean of the variables, so I picked 4. And I got a whole bunch of pseudo R squares and changes in pseudo R squares. I've got SES here as a level 1 predictor, keeping all the previous stuff in the model. Note that R decided it needed to reorganize my stuff, so I moved to this, highlighting it that it's at the end, but it's no longer at the end. So I put SES last, it reordered it to move the interaction to be last. Just a heads up. So SES at the child level is significant. Look at all those zeros. I don't like scientific notation, so I just let it keep going. So for every unit richer you are on a 1 to 6 made up scale, your achievement goes up by 0.1. Okay, not okay.
Are these in logits?
These are not in logits. This is predicting continuous achievement from pseudo-continuous SES at the child level, 1. I think either answer is correct. Okay is correct from one perspective, not okay is correct from another.
I guess if you're the school, I could see you not wanting that because you want achievement based on something else that you as a school can control, and not just how rich the students are.
Yeah, this is not a desirable outcome. My question is more like, is this a correct result?
Oh,
Like,
maybe
can,
is it okay?
is it okay like that poor kids have less achievement? No, that's not okay.
That's what I
But
thought you were asking.
we can't solve that problem in here.
Right.
That's a much bigger systemic problem. But my question is basically, is this model specified correctly? And I think there's an argument to be made that it is, and an argument to be made that it isn't. So I'm looking for someone to volunteer one of those two.
The not okay is because we're assuming we don't need a level 2, we don't have to control for level 2 variance.
Yeah, so the not okay answer is, no, this is smushed. You're assuming that the resources of the schools you go to, either of them, don't matter. However, what's the counterpoint? I'll go back up to where the counterpoint is. Schools don't matter. If there is no school variance in SES, it can't have a contextual effect. It doesn't vary at level 2. So from that perspective, this kind of gives you a license to smush, because functionally speaking, the ICC for level 1 SES is 0. Other than this little bias thing, but again, that's because of the one person per unique combination, I think. So this is where I think reasonable people might disagree. The person who made the data clearly intended it to be a within level effect, I can tell you that much. But in most cases, this I think would be a misspecified model. It is unlikely that your child level variables or your person level variables have no commonality to them in naturally occurring groups like this. Kids are not randomly assigned to their schools, workers are not randomly assigned to their supervisors, etc.
But the interaction is now good or better.
Yeah,
I
isn't
won't
that
say good,
interesting?
I'll say better.
Well, it's significant
Yeah,
now, which
significant,
I
which-
actually didn't even notice before.
Oh, I'm sorry.
Oh, no, that makes my story more interesting. It was the closest one.
It was close, but you
Yeah.
know, it pulled it, it reined it in, shall we say.
Are any of my sociology students here? No, they can make up some systematic reasons why this stuff would be. But I'm guessing that there's probably some correlation between your SES and where you go to school. There's something there and some kind of competing thing. So after you
Well,
control for this, maybe this has a chance to show.
Denominational, I won't say all the time, usually you are paying above and beyond for your students to attend, which is an associate.
Private school or religious school costs money.
Usually.
Usually, yep, so then in terms of including this new predictor in the model, it increased the level 1 R-square by 0.04, so it captured 4% of all the reasons kids differ from each other in achievement is because of their SES. It captured 6% of the variance, more variance in the secondary school intercept, so that indicates maybe a little bit of smushing or something, and then nothing in the primary. So I was like, well, let me show you how this would have looked. So I have SES for primary school on average, SES for the secondary, and SES for the unique combination as 3 separate contextual effects.
And that would be for the unsmushing if there was anything to unsmush.
Exactly.
Okay, I'm just making sure
Yep.
that I'm.
So which version of the model is this then, given that at level 1, SES is centered at a constant? Is this within contextual or within between?
Between.
Other one. If you leave level 1 alone, it still has all of the level 2 information.
Mm-hmm.
That's setting you up to have within contextual, because contextual is above and beyond level 1. Yep. So in the article that I posted to Icon, by the way,
I
and is
did,
referenced, they recommend cluster mean centering still. And my head broke in trying to figure out how to explain that to you, and so I just said, no, I'm not going to. Because then you have 2 different kinds of betweens, and within is within both. It seemed weird to me to think about like this between without considering the other between, so I thought contextual would be a little more understandable. So after you control for your child's own resources, is there an extra contribution of the school that they go to previously? No. The school that they go to now? No. And the unique combination of the resources across the 2 kinds of schools, and no. So these results to me are completely expected, given that there's no variance at the cluster level in this variable. So you wouldn't expect there to be much here, if anything. And my favorite error message that came along with this, optimizer NLWrap convergence code 0. Okay, model failed to converge with MaxGrad. It's like, no, stop it. Quit putting in constants as predictors. That's my translation. And the contextual effects did not add too much to the story. Okay, I think 2 more models. Random slopes. Let's talk about what's possible. There, go back to the beach for a minute. So normally, can level 1 predictors have random slopes over level 2 clusters? That's supposed to be a softball. Can level 1 predictors have random slopes over level 2 clusters? They can. You did it in your homework. Level 1 slopes have random effects over level 2 clusters. Like how much it sucks to be poor depends on what school you go to?
Oh, okay.
That. So can we have a random slope for student SES?
Sure,
Could it suck more to be poor in some schools than others?
sure.
What kind?
Both.
Both. Yeah.
It may suck me more, even more if you're in both. In the
Yep.
interactions,
And
right?
there could be an interaction, but yeah, we'll do one random slope at a time. So the specification here, though, takes a little bit of explanation. So I am keeping SES in the fixed effects as the constant centered version, so that my fixed effects would maintain within and contextual interpretations. I do not have that same choice when it comes to the level 1 random slope, to be random over level 2 clusters. Because if I were to put in the original SES, that would be a smushed random slope. I don't want that. So I am going to withinify it, another new word for your vocabulary list of things Lisa's made up, withinify by subtracting the cluster mean for the unique combination of primary and secondary. This is not in the article that you're reading, because they did not anticipate really the case where you have more than one observation per unique combination. But this takes away all of the primary and secondary information additively as well as interactively. So this new variable is completely uncorrelated with the cluster means. That's so we want it completely within, and that's what it is. And this one, let's see here. U2. Trying to track my own notation here. I have 2s. Why do I have 2s? Now I'm questioning myself.
Back up.
Yeah. It seems like there should be a 1. Like there's a model missing or something. Did I skip a layer? I think I did.
No.
No, I didn't. Okay. Well, the 2, I'll have to get back to you. Now I don't know why there's 2s here. It seems like I skipped something.
Maybe that's because you're using the cluster mean center version. instead of
Oh, it is, I think.
the original one.
Thank you, Vladimir. I'm not crazy. Yes. Okay, thank you. This all makes sense again. This is what happens when you make a handout 2 years ago and you don't go back over it until you're looking at it in front of your class. Don't do that, by the way. This is bad. Do as I say, not as I do. Okay, this one is 020 because it's the second one for primary.
Mm-hmm.
Okay, this one is 002 because it's the second one for secondary.
Mm-hmm.
This one is 022 because the second one for both.
Mm-hmm.
And, yes, because this was the notation crisis we had in your thesis as well about the
Exactly.
1s versus the 2. He's like, you're giving me nightmares again. I skipped over U1 because it would have went with this version of SES, and that's not the variable that this is tied to. So there's like an implicit beta 2 in here that doesn't have a fixed effect that has a random effect. Essentially, I had to add a second level 1 predictor by adding this in, but I only wanted to have a random effect because its fixed effect should be covered by this one still. Avoiding smushed random slopes. So in Stata, you can add a random slope directly to the dimension that is like the primary dimension, and you can ask for a covariance with it. So here's a bunch of stuff for that. In R, you have to make sure that it's in the right set of parentheses. So same idea here. If we want a random slope across primary, it needs to go here. However, without looking at anything else, tell me if you see anything that looks problematic.
Perfect correlation.
Perfect correlation. And a variance component that is 0 to 5 decimal places. Do we have a random slope? We do not. So this is an example of what would be called a non-positive definite random effects matrix. There's essentially no variance in the slope. It's not differentiable from the intercept. So you can see those error messages related to poor convergence or poor results when you have a zero variance, a correlation that hits the boundary of 1 or -1, or both. So without even looking at a likelihood ratio test, I'm going to say this model is not viable.
So, bye-bye.
Bye-bye. And my likelihood ratio test supports that conclusion. Yes?
Lisa, I have two questions about what we are doing here.
Mhm.
First, here we know that we have more than one unique case per cluster ID.
Yes.
Primary and secondary schools.
Right.
So you are doing the cluster mean centering using the unique ID,
Yes.
right?
Yes.
But in the paper that you shared, they use the specific cluster means, both cluster means, and they use the original level 1 minus the cluster means of the first group minus the cluster means of the second group, but they had unique cases only. In that case, do you think that there is a difference between both approaches? Yours using unique cluster ID means, or the one that we saw in the paper using both things additively? Do you think that there is a difference?
Yes, there is, and it's right here. So the question was, I centered, and let me go back to where I made the variables themselves. So the version of the level 1 predictor that I gave the random slope to is this one. It's original SES minus the unique combination mean SES. For the sake of comparison, I made 2 others within primary or within secondary. And not shown here, but I also tested that version where you subtract off the primary and subtract off the secondary. And the only situation in which the level 2 cluster means for primary, secondary, and their interaction, which are the first 3 columns here, were perfectly uncorrelated with the level 1 predictor is when I centered at the unique combination mean. When I centered, so if you center only at primary, then it's uncorrelated with the primary mean, but it's still correlated with secondary. If you center only at secondary, it's still correlated with primary, and by having the unique combination, it fixes both. In this data set, if you subtract off the primary and the secondary, like additively, there's still a tiny bit of correlation with the primary and the secondary. You need the unique combination. And this is what I had written to Jason about. I think it's because in their data set, they had 1 observation per unique combination, and so like that interaction is not separable. So in that case, I think subtracting off both the level 2 means is fine, but when there's a relationship like this, and when there's an unbalance in the relationship especially, that's when the interaction would have to be considered specifically.
Awesome. Thank you, Lisa. Now, my second question is regarding this idea of subtracting the specific unique ID mean. Because to me, those things work like clusters. So we have unique combinations. Let's say a subject is in school 1, primary 1, and secondary 1. That's a unique combination.
Yes.
If we subtract that unique value to the original value, to me the result would be 0 in all cases, but it doesn't make sense. I think that I'm missing something, but given that we will have as many unique combinations as subjects we have, if we subtract one value to one value, to me it would be 0. How does it work?
If there's only 1 observation per combination, then the interaction is like that person's score. Like the person is the level 1 unit is the interaction. It's the same thing. So it would be 0.
Yes. Yeah, but here we are not in the unique case. We have more than one
There's
case
more than one.
sometimes.
That's
okay.
why.
Okay, that makes sense. Thank you.
Yep. Yeah, so if you only have 1 observation per combination, so like in Dan's data, she has 1 response per subject per item, then technically speaking, the level 1 residual, I'm thinking of as response variation, but you could also think of it as subject by item interaction variance. It's not differentiable from residual. If you had 2 responses per person, like pre-post or something like that, then that interaction can be a separate random effect, separate from the residual, because the residual would then be the difference between pre and post for the same unique combination.
Yes. So, follow-up question, Lisa.
Okay.
When we have 1 case per combination, we can use the unique ID cluster mean centering. We should use the cluster mean centering that we saw in the paper, right?
Yes, if you have
Okay.
one observation and you want to do cluster mean centering, you would subtract off each of the crossed means, not the
Exactly.
combination mean.
Okay, now that makes sense. Thank
Yep. Yep. Okay. So we don't have a random slope? That's where we were? I'm gonna get through this handout come hell or high water. We only got like 2 models left. It's gonna happen. It's gonna happen.
No choice.
Yep. Now we gotta persevere. It was this one. Okay. So in your output, don't just go to the likelihood ratio test. Make sure to stop by your random effects table and make sure the numbers are not crazy. So crazy would be slope variances of 0, correlations that are at the boundary. And it doesn't print it in R, but in Stata and SAS and other packages, there's usually a standard error column, and those can go crazy too. So that would be another thing to check for if you're looking at other packages. So it looks like we don't need it. This is a significance test. What do you think of our power to even have this random slope across, across? Primary schools at this point. Do I have a lot of power or not that much power to detect a subject random slope across primary schools? I got 1,000 kids. Isn't that a lot? I'd take a sample size of 1,000 for most of the research studies I do. I'd call that a lot. But does that mean that I have a lot of power to detect whether the effect of being poor is bigger in some schools than others? How?
Okay, I think that, doesn't that go with your idea before where you said the number of schools was so small, you didn't have enough power because of that?
Yep, I got 50 schools. That's the power for this random slope. Random slopes are level 2 things. So you need a lot of units to be able to reliably detect a difference across units. So that's one thing. How can I argue against that? Well, maybe this is a type 2 error. Wheel. Effect sizes. So I computed a couple of things here. Here is the confidence interval for that random slope. On average, it's 0.09. And the variation around it implied by this model is a 95% confidence interval for that slope of 0.07 to 0.1. Pretty small. Slope reliability of 0.002. So I feel pretty confident in saying this is not here. And we can say the same thing about checking it across secondary schools instead to the same result. And the same, basically a constant rather than a variable for the slope with no reliability. Ta-da. So I'm pretty sure I've uncovered his generating model at this point. It included 2 random intercepts, no random slopes, and 1 level 1 predictor. Detective work. And here's some words. There, we got through it. That's all I wanted to say about that. Questions?
I'm glad I asked the question with some interaction using my dynamic example. But do I need interaction? Because I don't need to, because I have small sample size.
Which kind of interaction are you referring to needing?
Age, years of experience, interaction to inference that.
Okay, so you're talking about interactions among your fixed effects, your predictors. So how many teachers do you have? 118?
118. No, 118.
118 or 80? 80. Okay.
180.
118.
Oh, 118.
Okay, 118.
That-
So that's not terrible. Like that's not terrible. I think the question as to whether you should attempt interactions is partially going to be answered by the distribution of your predictors because they're all categorical. So you're going to need to look at like cross tabulations to see if you even have all the combinations of say ages and times teaching or whatever interactions you have because empty cells are going to complicate how you put those into a model. But otherwise, it's kind of up to you. Now, where I thought you were going is, do I need to worry about a random interaction between subjects and items? And the answer is no, because you only have one observation for each unique combination
Okay.
to that one. What about your other dimension? You have which of 3 subscales the item came from, right?
Yeah.
Do you think that that's going to matter? Are some items going to be rated higher if they come from one subscale versus another?
I think I've run, it's not significant.
You ran it and it's not significant. Okay, can we play along for the sake of my example? Okay, cool. So do you think that the subscale difference, even small, depends on the level of experience of the teacher?
Yes.
How would you operationalize that?
I, well, I did the, I think I was looking at the p-value was significant,
For the interaction term? Or,
no interaction.
okay, so could she do that? I'll open it up to the class. Could she fit an interaction between a teacher characteristic such as years of experience, and that's like a little, a lot, you know, it's categorical, and what subscale the item is from?
Why not?
I think you could. Now, what variance would it predict?
Maybe you can do like so there's three subscale under the category, right? So like one TKP, like 1 to 3. So maybe this one can interact with experience 2 with interact 3.
It would be multiple interaction terms, because yes, like if you have a baseline category and two other categories, then you would have to interact everything with both of those. So if it's a factor variable, then they'll do it for you. It'll do all the combinations. But yeah, it'll be multiple interaction terms. My question is, if you have one dimension, a cross-level interaction across the 2 level 2s is what we're talking about, what should that explain?
Level 2 variance.
Level 1.
Level 1, unless random slopes are involved.
That's
So
what I was
that's-
thinking, sorry.
Yeah, that's a new twist that shows up in example 5B, which we're not going to have a chance to start today. Sorry, don't cry. I'll make it up to you on Tuesday, I promise. If you have differences between people in how they respond to items, right? That's what we're talking about as a construct here. So like if you do something that makes your items harder, just as an example, and it really messes up some people, but other people are not as affected. That's a random slope. That's individual differences in the effect of that item manipulation. So then the next question is, okay, this really messed up some people more than others. Why? What is it about that person that lent itself to being more messed up than their peers? So in your case, it could be maybe the less experienced teachers are responding differently across the subscales to a greater extent than the more experienced teachers who don't make such distinctions anymore. Or maybe it's the opposite. Maybe those distinctions aren't relevant to the younger people, but they're super relevant to the older people. So these are random slopes. We can also have random slopes that go the other way. Effect of people things can vary randomly over items. That one is harder for me to think about. But there was one example, it was a task where subjects were responding to pictures of food. And some of the subjects had a history of eating disorders and some didn't. And so there was actually a random slope for subject differences in eating disorder history across items, where it showed up stronger in some items than others. And it was like the pictures of cake and stuff that like it tricked on, but not the pictures of like a baked potato. So, yeah, and so then you can explain why the subject random slope exists across items with item characteristics, like whether it's cake or potato. So there's a lot here is where I'm going with that. There's a lot more, but you understand the concepts, the key concepts. What's a fixed effect? A constant. What's a random effect? A variable. Question?
Quick one, Lisa. Yes, let's say that we have a cross classification design, but we don't have enough units for one of the type of clusters.
Mhm.
So we want to use some kind of hybrid approach or fixed effects approach. So can we include the cluster IDs of one of the clusters as a level 1 thing, as we would do it from a fixed effects approach?
Yes, so the question was, if you have one cross dimension that is basically not enough to sustain itself,
Yes.
can you just put in dummy codes, binary coded things, and collapse that into level 1?
Yes.
I'm gonna throw the question to Erica. She's like, what? In the data set you made up for the book chapter that we finished last summer, you did just that, right? What'd you do?
I put dummy codes in for which item it was. Remember we talked about intercept and not, remember? Like one time ago. But yeah, controlling for the items because I didn't care about that. I was just interested in the people and responses.
Yeah, so responses are nested in people, and each person responded to 5 items. 5 is not enough to do anything with. You're not gonna predict across 5 anything. So you just put in 4 dummy codes that says which item is which, fold that into the model, and then it's just responses within persons. Because the cross dimension of item mean differences are now accounted for by fixed effects instead. So like in this example, I could have had subjects nested in primary schools as the dimension that had 50, and then 32 dummy codes to control for secondary school membership as a fixed effect. Yeah, and that's what this is. I forgot, by the way, I had this explanation as to how Stata tricks their stuff into doing cross models, and it's kind of like that. There's an implicit dummy code thing that's happening here. That's what this all notation does. So that is also an option for cross dimensions that are either unstable or not of interest or not large enough to do anything with. Yep. The rest of these slides here, I'm not sure I want to go into because we didn't talk about longitudinal as much, but for those of you who are familiar with that content, I just wanted to give you a little bit of a sense as to how you could change time-varying groups in a model. You can essentially do it as a fixed effect or a random effect, where a fixed effect would be a time-varying predictor that is then a categorical indication as to what group you're in. So the second example in chapter 11 talks about that scenario where occasions are nested in students. Students change classes at each occasion, so students and classes are crossed. And in that case, you can control for what class they were in at each occasion as a fixed effect, or you could fit the crossed dimension as a random effect instead. So if you want to go random, you have to decide whether you think the effect of having been in a classroom leaves when they move, or whether it stays with you. And so then this example is talking about 2 different ways of operationalizing that idea, acute or something that transfers. There. Questions? Comments?
Question.
Yeah.
Could you use this methodology to help force, maybe more so, the use of prerequisites based upon student performance before and after, or before taking a class? You know, like if you were to group somehow.
I'm not seeing how this would lend itself to that. Can you say more?
No.
No?
I'm just thinking.
Okay.
You know, I'm just thinking, it's like, okay, yeah, success and, you know, students and prerequisites, and a lot of places made prerequisites go away to make it easier, but then it creates other issues, and I'm just like, you know.
Yeah.
I mean, maybe just a general study, and it sounds like how successful were students with the prerequisites compared to without, and you know, could you justify either keeping
do they have a
none
random
or-
effect for where they were before?
Yeah.
That's salient, I kind of
Yeah.
think. Yeah, I could see maybe incorporating something along those lines.
Anyway,
1:44, it's Thursday.
TGIT.
That's right, I say have a good weekend. Let us know if you need anything. We'll see you on Tuesday next week, hopefully after you have submitted your project check-ins, right? Right? Send me something to
project
respond to. If it doesn't fit neatly in the tables, then do whatever you want. I don't care. Just send me information.
Okay.
Okay,
Yeah.
thanks for being here.